let's make a game engine. Again. So you guys probably know I put out a video called Let's Talk About AI. We talked about how AI has completely changed the way that software engineering is done in 2026. And I think that a lot of it is very good, a lot of it is very bad. So what's the deal? Should you use it? Should you not use it? How do you use it? All excellent questions. It's a very controversial topic, and it's clear that a lot of people are very unclear on what the deal is with AI and software engineering. That's where I come in. I have some opinions to share. And what better way to share these opinions and discuss this topic of AI software engineering than practically by making a game engine. And most of you, at least I think most of you, I haven't actually counted, have said that it is in fact a good idea and they would love to see that. So today we're going to talk about what exactly that means. How am I going to make a game engine using AI? How am I going to make this into an educational YouTube series? How is any of this going to work? And I'm also going to be answering your comments from the last video at the end. First, we're going to talk about the game engine stuff. Okay, so first of all, you guys know the deal. I'm not a full-time YouTuber anymore. I want to make videos about things that I am interested in, and this is genuinely something I am really interested in. Do I know how it's going to go? No, that's the fun of it. We're going to explore this together, and hopefully I have enough experience, 10 years, actually much more than that, game engine experience that is. I have hopefully enough experience where, yes, we are going to be using AI to build this game engine, but we can still build a good product, hopefully. So the goal is very simple. Unlike my first game engine series, which I will have linked up there in case you want to check it out, that was a wildly different time. Unlike that series, which was quite deep and very slow paced and very, I guess, narrowly scoped. At least it ended up just being a 2D game engine rather than the initial goal of having it be a 3D game engine, because I realized that it was just too much. It was too much to go through every line of code that is put into a 3D game engine to actually make it work well. Like, the scope is just too big for a video series in which every line of code is written and thoroughly explained in the actual video. I tried fairly early on in that series to just merge code in and go through diffs and look at what that was like. Because that allowed me to, for example, write an entire event system and just go through the diff, not go through every line of code, certainly not write it out on camera, and actually explain the gist of this is what the system does in one video. But people didn't like that. People said, no, I like you writing code line by line. And so we went back to that style and everything just dragged on. And taking all of that and making that into like a 3D game engine would have just been just completely unfeasible. But at the time, I still really wanted to make a 3D game engine. So I did that off camera, initially by myself. Then people started volunteering. We formed together a little team. I even hired some people. We made Studio Cherno and we made Hazel, the big version of Hazel. Hazel Dev, as it was initially called, and then later just became Hazel, and the game engine series became Hazel 2D. Obviously, I'm glad that happened. That is now the technology base for Lucky Robots, and we're building a robotics simulator. So overall, I would still call that a successful project. And obviously, I learned a lot by making a game engine entirely by myself, or at least directing that team entirely by myself. And it would have 100% been impossible to do that, where every line of code was written in a video and explained as part of an educational series. There is a lot that goes into a game engine. You can get away with keeping it quite simple in a lot of cases, but nevertheless, there's still a lot, especially if you're writing it in C++ and you end up writing a lot of low-level systems that, of course, need to be properly written. Now, speaking of low-level systems that need to be properly written, Rust is another great programming language for that. And if you're looking to learn Rust, check out Let's Get Rusty, the sponsor of this video. If you're into low-level programming or you're a C++ developer, you've probably heard of Rust, the language that seeks to improve it all. It's always good to learn a new language because aside from the fact that Rust is getting more and more popular and people seem to love it. I mean, it keeps topping Stack Overflow's most admired language year after year. Aside from all of that, learning a new language just teaches you new concepts that you may not have thought about, concepts that you might even be able to bring back to a language like C++. So basically what I'm saying is there's no reason not to learn Rust. In fact, I think it could be very beneficial, and Let's Get Rusty is a fantastic place to do that. Let's Get Rusty focuses specifically on Rust education and job-ready training, and it's made by a fellow YouTuber with a YouTube channel all about Rust. Rust gives you all of this low-level control and performance that you're probably used to with a language like C or C++, but in a more modern way, with modern tooling, with strong safety guarantees, and with built-in support to make sure that your threads are behaving and you can write concurrent code confidently. All of this is exactly why companies like Google, Microsoft, and Amazon are adopting Rust more and more in production. Let's Get Rusty runs structured programs for individuals and teams, and they've helped thousands of developers over the years actually get productive with Rust, not just watch videos and forget everything. Go to letsgetrusty.com/start with Cherno. Link will be in the description below to find out more about their training. Huge thank you to Let's Get Rusty for sponsoring this video. Now, when it comes to the complexity of game engines, there are many different levels to that. It's very different to write a simple indie game engine than it would be to write a full-on AAA game engine. You could say I've worked with both because I worked at EA on Frostbite, but then I also wrote Hazel, which is very much an indie game engine and quite a simple one at that. Because I think that a lot of people just do not understand the complexity that goes into something that is AAA grade. It's actually fundamentally impossible to achieve that with a small team and from scratch, because a big portion of what makes a AAA engine and of that kind of grade is the fact that it has physically been around for like 20 years or more. That code base is mature. What does that mean? That means that it has been thoroughly battle tested. Lots of games on millions of different devices have shipped with specific code, and all of the edge cases, but what if this happens? This is like a really weird race condition or bug or edge case that could happen. All of that has been covered. The code is mature enough to handle all of that. If you make something yourself that of course is not just a copy of, AAA engine game code, there's no way you could have that. It's just impossible. It is just impossible. Of course, there are lots of things that make a AAA game engine a AAA game engine, and we can certainly discuss a lot of those throughout the course of this series. But the fact is, that is obviously an impossibly high standard to reach. Like literally, it's impossible. Now, making like a very simple indie game engine, I think is also a little bit boring, because I think personally, it's very easy to make a simple game engine. You just write the code however you like, really. And I mean, yes, you do need to learn some math, I guess, to do 3D graphics rendering. You need to be aware of lots of different techniques. And if you're doing it yourself, that might mean reading some papers, reading some books, probably looking at a lot of sample code. But for the most part, computers are fast enough, your GPU is fast enough that if you're trying to render like a simple 3D scene and make an editor around that allows you to author the data that the runtime's then going to use for your game, that's not that difficult. I mean, yes, I realize this is me saying this, and if I didn't know what I know, then maybe it would be very difficult, but I feel like that's just not difficult at all. And the reason I'm saying this is because that's not the kind of series that I want to make. So AAA is impossible, indie is easy, let's settle on something in the middle is my point. I think it would be fun to make a game engine that has some of these AAA game engine concepts, of course in a more simple, naive, narrow implementation, and in a way that demonstrates these more advanced features and concepts that I think are really cool to learn about, but doesn't go too deep to the point where we are more just building core systems and not actually producing a game engine that's capable of making a game. My hypothesis for this, using AI to build this, and we will talk about what that means exactly in a minute, but my hypothesis is this should be fairly achievable in a rather short amount of time. Now, my time is limited, and it's not like I'll be making a video every day. We'll see how quickly the ball starts rolling and I start making all of this stuff. But nevertheless, I think it shouldn't be too difficult to build something rather quickly that even has these advanced concepts in mind. So that is basically my plan. At least that is the product that I'm trying to build. A 3D game engine that is still simple, but utilizes some more advanced AAA grade concepts. Back when I made the game engine series, that was public on GitHub. It was just open source software. And then when I started making the 3D version of Hazel in my own time, that was accessible to patrons who helped support the series on Patreon. This new game engine that we're going to be building is just going to be 100% open source and available on GitHub for free. Of course, you can still access Hazel on Patreon. That is like 7 years worth of work pre-AI days, and to be honest, it's a great point of reference for many things. And if you do wish to support this new game engine series, then my Patreon will always be open for that, and that will certainly help with outsourcing the video editing, for example, so that perhaps I'd be able to produce more episodes more quickly. But again, I'm making this for fun. I'm making this because I want to. This is just an experiment. I don't know how this will go. So yes, of course, the code will be 100% free. Now, the next important thing that I want to talk about is this concept of building with AI. What do I mean by that? Am I just going to be like, make game engine and that's it? No, this is going to very much be AI assisted development. So I am going to use AI heavily for this. I want to push it. I want to see how good it can be. And I want to show people how they can use it to achieve a lot more than they otherwise would be able to achieve. But I'm also not 100% going to build this how I would build this if this was off camera. So to make this, in an effort to make this a bit more educational and useful to beginners, I'm going to not necessarily pretend that I'm a beginner and just ask it all of these questions and have it explain concepts to me, which if I was a real beginner, I wouldn't be able to validate anyway. I'm not going to approach it from that angle exactly, but I am going to try and perhaps use it to actually learn more or give me resources and guidance, more so than I would if it was just me confidently building something that in my brain already makes sense and I just need it to physically write the code and implement, these algorithms and make the code base. So that's something that I'm genuinely excited about because I don't know how that's going to go, and I'm going to try and put myself in the shoes of someone who has less experience and see what kind of product I can get out of this. But of course, Big Cherno will step in when necessary and be like, no, that's wrong, cut, let's start again. We're also going to have some fun with this series. So sometimes I may let AI do quite a lot and then code review it and then see, okay, this was great, this was not great, and point out to you guys what that difference is, at least in my opinion, of course. But there are also going to be times where I work with it to develop a strong architectural document, to plan things properly and make sure that that architecture is something that I actually want to see realized in the code, and then put it to work actually implementing that stage by stage, phase by phase, and make sure that it's doing basically what I would have done manually, but it's just doing it for me. So we're going to be quite strict with it in a lot of cases. We're also going to use it to develop tools along the way that help us validate and it to validate itself as well. So there are going to be lots of scripts, there's going to be lots of testing, there's going to be lots of documentation that we write for the AI agent to actually read before it does things. We're going to make like a bunch of different tools and skills, all of that stuff. We're going to do this properly. It's still ultimately going to look like code that I would have written. It's not like we're going to just let it do its thing and then not even look at the C++ code. We will read every line of code that it writes, and we will make sure that it is written the way that ultimately I would have written it, I guess, for the most part at least. And we will also make sure that it follows our code style, our conventions, that it ultimately does things our way and looks like code that we would have written. And by we, I mean I, because I'm the one making the series, of course. Now, as for which AI we will be using for this series, I'm going to start off using Claude Code. That's the one that I have had the most recent luck with, you might say. I'm sure that we will probably end up exploring other AIs as well throughout the course of this series. We might try Codex, we might try GitHub Copilot if they open that back up and we can select various models there. I'm not really sure, but we're going to start off with Claude Code. I'm not sponsored by Claude or Anthropic. I'm not sponsored by any of these AI companies, at least not yet. So I don't really care what we use. I'm just going to use what I think is the best tool for the job. So that is the plan. We obviously need a name for this new game engine, so leave your suggestion in the comment section below. I will also think about it. I have no idea as of right now what we're going to call it, but of course that is the hardest thing in programming, so we need to make sure we get that sorted out. When will this series start? I don't know, maybe in a month or so. probably pretty soon. I'm going to think about how I want to do things a bit more before we actually start the series, but overall I feel like I'm pretty much ready to start, and it will just be chill, it will be casual. It's not like it's going to be something that requires too much preparation, because again, I don't have time for that. And we're going to be in this journey together. We're going to go through a lot of this stuff together anyway and decide these things together, so it makes sense to just begin and see what happens. But a name. We need a name for this engine. So that means that in the first official episode of this, hopefully next month, we will start by designing things and just thinking a little bit about the goals, the architecture, the types of systems we might want to make. I'll still give a normal overview. I want this to be educational, obviously, to people trying to build a game engine. So I will still give we might not even use AI next episode for episode 1. I might just draw some diagrams and talk about, okay, what is the plan for this engine? How are we going to architect it? What kind of systems are we going to do? And then we'll probably begin. It'll be just like the OG game engine series. Nostalgia. Okay, so that is pretty much it. That is my plan. Leave your thoughts in the comment section below. Let's read some of your thoughts from the last video. So over 1,300 comments. You guys definitely commented a lot. I definitely haven't read all of these. My wife, though, who loves reading my comments, has let me know about some of them, so thank you. But anyway, let's go through some of these now, and maybe that will help answer some of your questions and my thoughts about AI as well. So there's a big difference between reviewing code from a junior and code from AI. The junior might actually learn and improve long term. Okay, I feel like that's a bit irrelevant. Meanwhile, the AI will not become better long term based on your feedback, which will only live on in its memory. Yeah, but you're not training. Okay, so in this case, I guess this would imply that you're trying to actively train AI to replace the junior. You want the AI to be the replacement for an actual junior engineer. That's obviously not what I'm talking about, because in this case, in this scenario, the junior would be using AI. So the junior would be learning and keeping everything. It would be the thing that lives on in its memory permanently. And then the AI would just be a tool that the junior uses to implement the code. So in that sense, the junior is still obviously learning a lot, still getting feedback from senior engineers, probably getting feedback from AI as well, because at that level of experience, the AI would obviously know a lot more than the junior would. But the only thing is the junior has to be a lot more intentional, a lot more disciplined, and not lazy to make sure that they keep themselves in check and that they are actually digesting all of this stuff that AI is telling them, everything that's being written, they understand and they actually learn from it, not just blindly accepting code because it goes over their head, they don't understand it. So in that sense, I think juniors do need to be more disciplined, but obviously there is still the junior. No one's talking about replacing a junior. At least I'm not talking about replacing a junior. The idea that junior can catch up by using AI is ridiculous. They will barely learn anything in the process. Highly disagree with this. All the work of verifying, teaching, and feedback will be responsibility of the rest of the team. This is the case with a junior as well. This is the case with a junior on your team as well, regardless of whether or not they're using AI. You likely would get people learning a lot slower as a result. I disagree with this. I think that more than ever now, juniors who are actually really self-driven, disciplined, who want to learn a lot, have this amazing resource now. They can ask questions and get them answered. I remember when I was like 19, I was in university, I really wanted to learn more about game engines and like C++ programming and graphics programming. I just loved that stuff. I was really passionate about it. And no one in university, at least no one in my university, could help me to the degree that I wanted help. I would ask them questions, they wouldn't know the answers to them because, I don't know, they're either career academics or they just haven't had C++ game engine experience. Like that is kind of a specialization. It's a bit of a narrow field. It's not just like C++ programming in general. I mean, C++ isn't even that popular of a language compared to like, say, JavaScript or like Java or C#. Like C++ is more of like a low-level systems language. Like it's not something that all of these lecturers are going to have real industry experience with. So that was like quite hard for me. I was frustrated constantly. And then searching stuff online, like it's hard. It's hard to get concrete answers to like difficult questions just by Google searching. But then I started working as an intern on the engine team at EA. Working on a game engine in Australia in 2015 was like, a handful of people did that. A handful of engineers were working on a AAA grade game engine in Australia. But I was fortunate enough to land on that team. And suddenly, when I asked questions, they'd be answered like that it was like a superpower. It was absolutely amazing, and it was such a useful resource to be able to ask all these questions and have them instantly answered. And this is now what kind of exists with AI. Like, yes, people like to say that AI often gets things wrong and it often hallucinates. And like, yes, that does happen, but in general, it does provide a lot of really valuable information that you would otherwise have no easy way of obtaining, especially if you're not within the industry. So this concept that they will barely learn anything in the process by using AI, that is ridiculous, Mr. Cool 56. I highly disagree with that. I mean, just to give you an example, download the Unreal Engine 5 source code, which is available, open up like a Claude agent in that repository and just ask it to like generate a report on certain systems or tell you the general architecture of this. And then you can keep asking it questions. Okay, but why did they make this decision? Why is this line of code written like this? What's the deal with this? And it will give you like a lot of really useful information. How on earth would you do that if you didn't have AI? Like, I think people genuinely don't understand just how different things are right now with this technology. But you need a special kind of junior that, again, is going to put in that effort to actually learn from AI and like also talk to the other engineers on the team for sure to make sure that what it's saying is correct. Like, yeah, there's still that skepticism, but like, you know, a senior engineer is also capable of saying things that are just incorrect. Like it's not like the human senior engineer will always give you the 100% correct answer and AI will always get things wrong. Lots of engineers, regardless of their experience level, will also make mistakes. So multiple sources, multiple references, always important. Every line of code almost is a design choice, be it a really small design choice. It could matter a lot. It might shape how we think about the code in subtle ways. I don't feel like I own the code that the agent writes for me, which makes it difficult to even remember. This is true. This is something that I think is quite a real problem, because just the action of typing, it's like if you're at a lecture and you hear things and that's all you do, you just listen. You're not going to remember that anywhere near as well as if you were also taking notes and writing stuff down. That's sort of like, it's going to use different parts of your brain and you're going to retain that information a lot better. With AI, if it's writing all the code for you, because you didn't physically type it out, I agree with this. Like, it does make it harder to remember. And it's also more exhausting reviewing the code because I have to populate my mind with what the LLM wrote. And that requires a lot of discipline and mental effort when I see a lot output from the LLM all at once. Yeah, these are all completely valid points. But I will say that if you are working in a large code base, this is just a general problem because there's lots of parts that, of course, you wouldn't have written. Stuff changes very rapidly. There's lots of engineers, lots of different teams working on essentially a single kind of code base, even if it is modularized, which is why a lot of like high-end software engineering is more about reading code than writing code. And I guess in this case, yes, it will make things potentially harder to remember than if you had written out the code. And the volume is just more as well. That's all valid. My biggest problem with AI is it's meant to replace humans. There needs to be laws in place to protect workers' jobs. Corporations don't care about how many people they lay off because paying less people equals bigger profit margins. I mean, I agree with some of these. This is just like, this has been the case forever. This is not new because of AI. If anything, I think maybe smaller companies are more likely to lay people off because they can collapse like 3 people's jobs into one, and they care a lot more about, you know, maintaining their thinner profit margins. That may be new because of AI, but in general, like layoffs have happened all the time, and like overhiring happens very easily as well for large corporations. Whether or not it's more than it otherwise would have been because of AI is also a question that I'm not sure I know the answer to. Laws in place to protect workers' jobs. So the thing is, like, AI is so broad. When it comes to software engineering specifically, the thing is that there's always sort of a lack of software engineering effort. There's always more work to do. There's always more products to build, to refine, to research. There's so much that needs to be done that, yes, you could look at it as AI has increased software engineers' output. So by, let's just say 3 times, just as an average, whatever, I made that up. 3 times it's increased their output. So we need 1/3 of the engineers to achieve the same amount of output that we had before. That's one way to look at it. We can just lay off 2/3 of our team. But another way to look at it is our output has increased by 3 times. That's great. That's what we want. Let's keep all those engineers because now we're achieving 3 times the work we were, and that's amazing. 3 times more work should translate to more profit and more revenue as well, presumably, if you're running this well. It's also a bit of a situation where a lot of the people getting laid off, unfortunately, are just low performers. They're just, especially at these large corporations, they can get pretty cruisy, those jobs. Those people can get pretty lazy. Not saying this is everyone who gets laid off, but I feel like a lot of these people getting laid off, there's a reason why they got laid off compared to other engineers that didn't get laid off. And now that the output has increased so much, if you're unable to keep up with that, then yeah, it makes sense that you fall into like that bottom percentile and you will just get laid off. Especially, of course, if the company is trying to cut costs, which generally they probably are. Now, is it fair that the output has suddenly increased and you're expected to do a lot more work? Well, it's unfortunate, but this is technology, this is industry, it evolves. Things change. You now have a tool that allows you to do a lot more. It's definitely not 10 times more or 100 times more. That's crazy because, again, you still need to be making sure that you are engineering the code. You're just using AI to help you, not to do it for you. But I think it's fair to say that like my output has increased, but my output has increased naturally. It's not like I'm having trouble keeping up with it. Like I have this tool now that does a lot of it for me. And even with all of the guiding, the reviewing, the making sure that it's doing the right thing, it still does it a lot faster and better than I would have in the same time frame. Like that is just a fact in my experience. Maybe I'm using it better than a lot of other people. Maybe also I have the experience to make sure that I'm using it properly and that it's doing a good job. For me, I set a rule for myself that I will write the code myself and only use AI for researching for stuff I'm not aware of or understanding a topic, but the line of codes, I will write them myself. This is also a valid way to use AI. I mean, I like using it to write stuff for me, but using it for research is also very valid and very valuable. But I have a suspicion that as time goes on, people who are doing this will also start to switch across. I sat through this whole thing. So someone's studying game dev at uni and I'm very deliberate about my learning journey. This is very, very important. Just as I have learned to type faster without looking at the keyboard, I hope one day I can write code without using AI all the time. And I still do write code. It's just that, again, you can use AI in so many different ways. And one of them might be just write some functions for me, just some scaffolding, some empty functions for me in this format. That's going to probably be quicker than me typing them out manually, especially if there's like a lot of them. But then I might choose to actually go through and hand write that function. Like that's a thing that still happens. Maybe you want to be super deliberate, super precise about it, and you just don't want to go through AI for that because maybe that will even take longer if it's something relatively simple or something that does need some surgical precision. I think a good comparison to that is handwritten assembly. Like FFmpeg, for example, has a lot of handwritten assembly. They could have used compiler intrinsics. They could have just let the C++ compiler with vectorization turned on do the SIMD stuff like for them, but it's just not as good as the handwritten assembly. Even now, after all of this like compiler development, it's still faster and more precise to handwrite assembly to do those performance critical operations. As is with AI, a lot of the times what you get is just not what you're looking for, and it's just faster and more precise to handwrite that C++ or whatever programming language you're using yourself. I will say though that there are also many different levels of AI. If you just ask it to write something for you, it will probably pick a simple, common solution. But if you make it known to AI that, whoa man, like this is AAA grade, like you're playing with the big boys now, I need you to write this in this way, then it is also capable of doing that. The thing is, it just won't do that. It won't do that by default because it's not the most common solution. It's going to go for something maybe a bit more simple that will save maybe some more tokens. It doesn't need to reason about quite as deeply. It will just go for that unless you're very deliberate with the kind of code that you expect from it. And again, this comes back to you having to have experience and some knowledge because otherwise you don't know what is good and what is bad. And that's a very dangerous position to be in with AI. Okay, thank you all for your comments. We'll probably read some more of them, and feel free to leave your thoughts, of course, in the comment section below for this video as well. It's gotten very dark here. If there's anything you want me to know before I start this game engine series, maybe specific direction that you want to give me as well, or to make sure that I include certain things as I'm making these videos, definitely let me know as well. But thank you all for watching. I'm really excited to start this new series. I will see you next time. Goodbye.